Hello everyone and welcome to this video on memory hierarchy. So first let us understand what is memory hierarchy. Memory hierarchy is the layered arrangement of memory types in a system. It is based on speed, cost and size. Faster memories are placed closer to the CPU but they are smaller in size and more expensive, while the slower memory are cheaper and larger in size, placed further from the CPU, and this aims to the balance speed and cost. Now let us see the memory hierarchy pyramid. So here, as you can see, these memories are transit from fast to slower. So here you have the faster one and this goes down towards the slower one. Here each layer serves a specific purpose in optimizing data access and system performance. As you can see, the topmost layer is having register, then we have a cache memory, then RAM, you can consider it as a main memory, then a secondary memory that are HDD or SSD, and then last we have the backup storage. Now let us understand this one by one. So first we start with the level 1, that is register. Registers are the fastest memory type located directly inside the CPU. They store intermediate data, what we can say the current instructions, right, the intermediate results and the addresses needed by the processor. They are very limited in size, typically 32 or 64 bit, right, and this include the instructions registers for storing the instructions, data registers for storing the intermediate data, or we can have an address register to store the addresses, right, and this is used during the arithmetic and logical operations, right. So this is registers. Now let us move ahead with the second level, that is a cache memory. You might be aware of the cache memory. It is the smallest and high speed memory between the CPU and RAM. It stores frequently accessed data and instructions. It takes from the CPU and to access the memory. There are basically three types of cache memory, right? You can have this, you can see here L1, L2 and L3. L1 that is closest to the CPU and it's the fastest one. L2 is a larger but bit slower. Then L3 is a shared across the CPU cores, right. So this cache memory, as you might be aware of, that frequently accessed data we can store here. That means it reduces the CPU wait time, because usually if we bring the data from the main memory or a secondary memory, it will take a time. So for reducing the CPU wait time, we have cache memory, right. Then next we have main memory. Everyone is aware about this main memory. We can consider it as a RAM, random access memory. As everyone is knowing, it's a volatile memory. Volatile memory means what? When the power is off, all the data will be vanished, so that is volatile memory. It is used to store the currently running program, the data that are currently used, that is stored in volatile memory, the programs that are stored there. When the power is off, as I told you, that when the power is off, all the data is lost. Why? Because that's a volatile memory. Then RAM is slower than cache memory. Earlier we see cache memory. Cache is faster but RAM is slower, but it is faster than the secondary storage. So in the pyramid you might be seeing that it is like below the cache but above the secondary storage, right. That means it is faster than the secondary storage but it is slower than the cache memory. In that RAM we have two types, SRAM and DRAM, right? SRAM is a faster, usually SRAM is used for cache memory, and DRAM, that is a common main memory type that everyone is using, right? And this main memory is used, it is accessed via memory address bus. In my other video you might be seeing that you already seen the video of address bus, right? So it is used, it is accessed with the memory address bus, right? Now the next memory, that level 4, level 3 is a main memory. So level 4 we are having, that is a secondary storage, or we can say a secondary memory. Now it includes our hard disk, our SSD, right? HDD, SSD, right? So it's a non-volatile memory. As we already see that RAM is a volatile, while secondary storage is non-volatile. The purpose, we store a long-term storage, right? We can store the data for a long term, right? So it stores the OS, it stores the files, it stores the application, all the data that are permanently stored in our laptop or PCs that are using the secondary storage. This in this we have HDD and SSD. If we compare these both two, so SSD are faster and more reliable, HDD are a bit slower than SSD, right? So the secondary storage provides a massive storage capacity, right? It's much slower than RAM, it is slower, but it the main objective of the storage is for mass storage, right? So larger in capacity, usually in a GBs or TBs, right? Then the last but not least, it's important one, that is a backup storage. Most people forget this big backup storage. Usually people only say like 4 layers, 4 levels, but we have this level 5 as well, that's a backup storage, right? So backup storage is used for long term data backup, right? And sometimes like some disaster happens, so that disaster recovery also we need this backup storage, right? It includes like external hard drives. You might be aware of external hard drives, USB drives. Then currently we are using like in a massive, we are using cloud storage, right? So like for example Google Drive, we are using Google Drive, right? So this is what that is backup storage, right? So it is very large in size but very slow access speed, right? In that pyramid also you can see that it's a larger at base, right? So you can directly came to know that it's in a larger in size, while in a register was the first one, right? So first one, that the pick is very smaller, right? So you can assume that that's a very small in size, but it is a very faster one. Same way here also, this backup storage is a base, right? The last one, level 5, so it is having the large size capacity, right? Now it provides data security, right? And as I told you, disaster recovery, right? Disaster recovery can be done, right? It is not used for day-to-day processing, but when we use some data, like when we required some data, at that time we can retrieve that data from my backup storage, right? So that's level 5 backup storage. Now next let me just summarize this, right? So here you can see the table where all the memory, all the level, like level 1, 2, 3, 4 and 5, right? All 5 level is summarized here. That you can see this register are the fastest one, right? As the speed is very high, but it is the smallest in size, and the cost is also very high for this. Then comes cache memory, that is high in speed, that is like its speed is lesser than the register but higher than the RAM, right? Even the size is small, and the cost is again high. Then comes RAM is having a medium speed, normal speed, right? It is having a medium size and a medium cost, right? Then comes our main memory, that is HDD SSD, that is having a low speed, large in size and low cost. And the last one, level 5, that most of the people forget, that backup storage or backup memory. So its speed is very low, the size is also size is very large, right? And the cost is also very low, right? So I hope you understood this memory hierarchy, right? So if you have any doubt, you can ask me. That's all from my side. Thank you very much.